Okay, so I had a student question about his mass properties on his Crucible Bucket, and my response is going to be that as long as you're within about maybe 30 pounds out of 12,000 pounds, that's pretty good. And so I went back to the very beginning, kind of checked your mass properties, and it was pretty close. From the very beginning, it was only off by about 10 pounds, from my model. But even my model is off. So if you take a look at my model and do the mass properties, you'll notice one thing over here too, because of the loft in here and the shell. I kind of have some surfaces back here that are not quite tangent. They're supposed to be made tangent. In fact, you might want to check that if you right click in your feature over here. You want to make sure that you merge tangent faces in here, but it didn't do that after I put in the shell feature. It kind of created these other faces in there, and I saw different shapes from other different models. But the thing about lofts is that they're not very reliable sometimes. And the reason for that, if you were to go into that loft and take a look at that, and take a look at what you have here, typically like with a hammer handle, which is another loft that we did, they were all round features. There wasn't a straight edge on any of that, and it actually resolved itself pretty good, a lot better than this does. And with that hammer handle, we did not have these guide points, these pull points in here. So one thing about these pull points, if you pull these around and move those around a little bit, you're going to get a different value. I don't know why. It's just the way lofts actually manifest themselves. But if we kind of exaggerate that a little bit and go ahead and rebuild that and take a look at what the mass properties might be in this, we're going to see something that's a little bit different than what was there before. So if we go to mass properties and take a look at this, and here it is, and we're going to go ahead and take a snapshot of that. Well, before they do this is what the mass properties were before, and now they're off by about 6 pounds over here, but center of mass is actually pretty close. So this is what it was before we took those pull points and moved those around, and this is the way it is afterwards. So pretty darn close. 6 pounds out of 6,000 or 6 tons. That's pretty good. So I wouldn't worry about that. What I'm looking for is having mass properties that are pretty close, within about 30 pounds, one way or the other. I think if we do that, I think it's pretty obvious you got something that's really close. One thing to note here too, so as long as we have the mass properties dialog box open over here, you notice that we do have a symbol in here in the middle, and that shows you where the actual center of the mass is. And what I was trying to do, both on the right plane and the front plane, is try to get that as close to the middle as I could. I want to make sure that the center of mass was actually below where the revolve feature was too, because this is a virtual bucket, and if it pours virtual steel, it might molten steel, you might virtually get hurt. But we want to make, you want to think about things like that. So you notice that it's only off in the Y direction, which is going up and down vertical. And in regard to the X and the Z axis, trying to keep that in the middle as best I can. But when you see that symbol, that's where the actual center of mass is. So anyways, everything looks good on the student model. And I think you can probably go from there. So actually, let's just do the mass properties in the student model. So his is a little bit different too. 12058.118, and mine's 12068.44. So off by 10 pounds. Not bad. So continue on.